Today, we're going to be learning about percents and percentages as ratios. Remember that a ratio is a comparison between two amounts, and a percentage, percent actually means per 100 or out of 100. And so percentages are ratios where we're always comparing our number out of 100. The denominator is always going to equal 100. So we're really going to be connecting our new understanding about percents to what we already know about ratios and what we already know about fractions. We are going to be looking at fractions, decimals, equivalency, and percentage. So let's take a look at our vocabulary for today. Okay, first up we have a ratio, which we already talked about for today. A ratio is a comparison of two quantities, but we use division, or you can write it in fraction form. And so we want to think about that because that's what we're going to connect to when we start with a fraction or a ratio and then rewrite it or convert it into a decimal. It's that division piece that's involved. Our second term is a percent or percentage, and this is a ratio that compares a number to 100. So percents are ratios. It's a comparison to a part to a whole, but that whole amount is always going to represent 100 or out of 100. As mentioned before, percent means per 100. So our denominator will always be 100 when we set up that ratio comparison with a percentage. Our next vocabulary word is equivalent, which means having the same value or meaning. And this is important when we're talking about percentages because all percents can be written in fraction form out of 100. And so if we have a fraction that we start with that is not out of 100, we can convert it to decimal form, find the percent, and then rewrite it as an equivalent fraction out of 100. Now we're going to look at terminating decimals and repeating decimals. So a terminating decimal is a decimal that terminates. And to terminate, you can think of like the Terminator, is to put an end to or make something stop. So terminating decimals are simply just decimals that stop. Like if I said 25 hundredths, 0.25, there's no more decimals going, it stops, it's a terminating decimal. Now, a repeating decimal does not stop. It keeps on going and repeating and repeating and repeating and repeating. So an example of that would be like 0.3 repeating, 0.33333333333. So repeating decimals go on and they don't stop. And they can also be written in fraction form. So we're going to look at today converting fractions into decimals, and we'll be able to identify whether they're terminating decimals or repeating decimals. Lastly, we're going to look at benchmark fractions, which benchmark fractions are ones that we can refer to when we're estimating. Benchmark fractions should be easy for you to recall. So for example, 1/2, the fraction 1/2 is the percentage 50%. And so those benchmark fractions, we're going to relate to percentages and see what those connections are between the two. So let's get into some practice problems. Okay, for our first set of practice problems, we are going to start here by filling in the box, each of the boxes to find the percent. So you can see that progression that I was speaking of earlier. We're going to start with what we know about fractions, convert them into decimals, look at what that looks like visually in a hundreds grid, create equivalent ratios, and then finally we'll write what our percent is, what is 1/5 as a percentage. So remember that all fractions are decimals, and 1/5, okay, a fraction is part over a whole. This is the part. 1 out of 5 is the whole amount, and 1 divided by 5 is what the fraction is. So the 1 goes on the inside of the tent. 1 divided by 5 is our divisor. And so then we say 5, can 5 go into 1? No, it cannot. So we add our decimal point and drop in a 0. 5 goes into 10 2 times. So 2 times 5 gives me 10, and it goes in exactly. So as a decimal, the way we say this decimal is 2/10, which is also how I could draw it in my hundreds grid. So you can see that there are 100 tiny squares here, not cubes, and each row, or this would be column, I guess, has 10, right? Going up and down. So write what I just shaded in would be 2/10, yes? Okay, that's what 2/10 would look like. But if I counted each of these tiny squares, okay, the tiny squares, if I counted them all up, this would actually be 20 out of the 200. So we already have two equivalent fractions that we can now write in our next column. We have 2/10, because I'd have two strips of 10, is also equivalent to 20 hundredths, okay, which is also equivalent to our starting fraction 1/5. Okay, and you can also sort of see the when we talked about equivalent ratios, we talked about what that progression looks like, which you can create them by multiplying or dividing the same the numerator and the denominator by the same number, and we can see that pattern here when we go from 1/5 to 2/10 to 20 hundredths. From here I multiply times 2. And so 1 times 2 gives me 2, 5 times 2 gives me 10. From here I multiply times 10. 2 times 10 is 20, and 10 times 10 is 100. So those are three equivalent ratios. Can you think of any more? Let's finally finish off by writing our percent. So we know as a decimal, 1/5 is 2/10, and we know in our hundreds grid, it's 20 out of 100, which that's how we write percentages out of 100. So that equals 20%. You could also look at your decimal and increase it, multiply it times 100. So 0 and 2/10 times 100, and that's the same as moving your decimal point 1 2 times. So again, we get 20%. All right, let's do one more problem. We're going to do 1/3. So remember, all fractions are division problems. This is 1/3, which is the same as, let's change it to my highlighter, it's the same as 1 divided by 3. Okay, the way we say it is the way you write it. So 3 does not go into 1. So I put a 0 and my decimal point, drop in another 0. 3 goes into 10 3 times. 3 times 3 equals 9. 10 minus 9 is 1. 3 can't go into 1, so I add in another 0, and I have 10 again. So I say 3 goes into 10 3 times. 3 times 3 is 9. And then we're going to start to notice a pattern that every time it's going to be 10. And we call this, which was one of our vocabulary words, a repeating decimal. The 3's will continue to repeat. Okay, so instead of writing 3 over and over, we can just write 0.3 with the line above it. That's the repeating sign. Okay, so now what does this look like in our hundreds grid? And 1/3, so we have 0.3 repeating, which technically this is 3/9 as a fraction. It's not in tenths because it's repeating. But we're gonna take since it's out of 100, let's fill in 33 squares. Okay, so also you can think of place value. This is the tenths place value, so that's a fraction over 10. So, and like I said, if it wasn't a repeating decimal, if it's just 0.3, we would write that as 3/10. Anything that's repeating is actually over 9. And then 33, this is the hundredths place value, so it would be 33 hundredths. And actually it would be 99 since it's repeating. So we're going to fill in 33 squares. 1, 2, there's 30, 1, 2, 3. And then 0.3 repeating, because the 3 is going to keep on going. Okay, and we're not going to be able to draw that. So equivalent ratios. So 1/3 we said right here is actually equivalent to 3/9. Okay, and that pattern would be times 3 times 3. Okay, and 3/9, if you divide it out in your calculator, it will give you repeating decimal. And as a percentage, we can reference back to what we just did here. Out of 100, remember all percents are a fraction part to whole comparison, but the whole amount is always 100. And so it would be 33.3 repeating, right, would be as a percentage. So I would write it 33.3 repeating percent. Now I'm going to give you a picture. That's what you're going to start with. You are going to write the fraction based off of what you see in the picture. So we'll go from the fraction and then you're going to convert it into a decimal, and from there we'll write it as a percent. So use the image to determine the fraction, decimal, and the percent. Okay, so we have, remember that all fractions are part to whole comparisons. So we want to look at the whole bar or the whole picture and count how many pieces. The whole is how many, the denominator is always telling us how many pieces are in the whole amount. So we have 1, 2, 3, 4 pieces in the whole amount, and then the numerator tells you the part that you get, which is in orange. And I have 1, 2, 3. So you get 3 out of the 4 pieces. So our fraction is 3/4. And all fractions are division problems. 3 divided by 4, which is the same as 3 divided by 4. So 4 does not go into 3, so we add a 0 and a decimal point. Drop in our 0. Excuse me. 4 goes into 30 7 times, right? 7 times 4 is 28. 30 minus 28 is 2. 4 does not fit into 2, so I drop in another 0. But 4 goes into 20 perfectly, nice and perfectly for us, 5 times. So 5 times 4 is 20, and now we have a terminating decimal. We have our answer, 75 hundredths. Okay, and remember the way we say it is also how you can write it. This is the tenths, this is the hundredths place value. The 5 is in the hundredths place value, which is the same as the fraction, 75 hundredths, which as a percentage is 75%. Or you can take your decimal, 0.75, and multiply it times 100 because it's out of 100, and you can do all of the math, or times 100 is the same as moving it 10 times the place value, 100 times the place value. So 2 decimal points, which gives us 75% again. So 3/4, the fraction 3/4 is the percent, 75%. Let's do number 2 here real quick. So let's look at our picture. Remember, all fractions are part to whole comparisons. The part is the numerator, the whole is the denominator. So that's telling us how many pieces are in the whole amount. Let's count 1, 2, 3, 4, 5, 6. The dot didn't show up. So there are 6 slices in the whole pie or pizza. But the part that you get is what's shaded. So 6 minus that 1 slice means you get 5 of those slices. 1, 2, 3, 4, 5. So this is the fraction 5/6. And remember, all fractions are division problems. 5 divided by 6. So 5 divided by 6. And we're going to say 6 goes into 5 0 times. So I add my decimal and drop in a 0. 6 goes into 50, so let's see, 6 times 6 is 36, so that's too small. 6 times 8 is 48, so let's try that. 48, I have 2 left over. 6 does not go into 2, so I'm going to drop in another 0. 6 times 3 is 18. So that gets us close to 20. 3 times 6 is 18. I subtract, I get a 2. Uh-oh. So I'm going to start recognizing a pattern. I bring down, I have a 20 again. So it's going to go in 3 times. 3 times 6 is 18. And now we know that this is a repeating decimal. So remember, this is the tenths place value, the hundredths, thousandths place value. So it would be 83 hundredths, or we can think of this as 83.3 repeating percent is how we would write that. Okay, 83.3 repeating percent. Today we learned about percents, and we know that percents are all ratios, and the comparison for percent is per 100 out of 100. And so we looked at what that equivalency looks like from a decimal to a fraction to a percentage, and just connected all of what we know about division, what we know about fractions, and what we know about ratios to understanding percents. If you feel like you need more understanding, you want some more help in better understanding ratios, which really are our building blocks for percents, check out these videos. And don't forget to like and subscribe for more weekly math tutorials. We'll see you next time.